This is Chem 433, Polymer Chemistry. We have a question here to deal with. The question says, write equations for the polymerization of styrene initiated by benzoyl peroxide. Show all the steps. Okay, let's see how it is being done. Solution. Now write equations for the polymerization. Now when we talk about polymerization reaction, it is actually a reaction whereby is a reaction whereby you bring smaller units, little small units. Now the small unit we have here is a styrene, so you bring them together. So when you keep bringing them together, that's what we call polymerization reaction. But let's not go there. I was trying to explain them. So what we have here is benzoyl peroxide. Benzoyl peroxide. So bring your benzoyl peroxide. That's why as a chemistry student, you need to know this, the structure of your molecules. The structure of your molecule. So let's see my benzoyl peroxide molecule, how it looks like. Now, by the way, before you even start doing this, you have to know this is an addition reaction. Okay, when you bring two things together, you keep building them. That is addition or chain reaction. So now this work can be done, has can be done in three steps. So it involves three steps. So the first step is initiation, the second step is propagation, and the third step is termination step. So once you finish initiation, propagation, termination, that's where you have your answer. So let's look at the first step, which is initiation. Initiation, which is the first step. So here in the initiation stage, you bring your benzoyl peroxide, which is this. This is my benzoyl peroxide. See, it's a structure here. Okay, follow up. Okay, this is the structure of my benzoyl peroxide. Very well. Now, for what you need to do at this stage, or in this particular stage, you have to heat this your benzoyl peroxide. Yeah, why do you heat it? So you can remove the carbon dioxide. What we are interested in is in the free radical. So we are interested in the free radical. So where you have, that means in that case you have to remove all these carbon that are here, carbon dioxide that are here. So if you for you to be able to remove this carbon, you have to heat it. So if you heat this is going to break into two. If it breaks, this way it's going to break. It breaks here. This way, this particular bond that hold the two of them together will break. So if it breaks, that means this is how it will break with a single arrowhead. Another one will come here with a single arrowhead. That means this very particular single bond that is here contains two free radicals. So one free radical will come here while the other free radical will come here. See how it looks. So in this case, if it breaks, it's going to be like this. This is how it's going to be. Okay, now remember I told you there's a free radical, so it will form here. So the same thing will come and form here. So in that case, it will be two of these. Do you see it now? But we are interested in this, we are interested in this very particular phenyl radical. So in that case, and I told you we need to remove this carbon dioxide here. So in that case, you have to heat it again. You heat it again. This symbol stands for heat. So it will break here will break. Remember I told you if it breaks, one will come here, okay, and one will remain. So in that case, you are going to have something like this. So if it breaks, one free radical will be there. Remember this was 2, so 2 will have to be here. And so you have your carbon dioxide here. So this free radical that comes here, this other one will come and combine with it, and it will become another bond there. So in that case, it's going to be carbon dioxide. Remember, it was in 2, so 2 comes there. So we have gotten what we needed. This is phenyl phenyl radical. This is phenyl radical. This is my benzoyl, okay, benzoyl, benzoyl peroxide, okay, okay. So once you have this, bring your free radical, then initiate it with the styrene. Understand me? Or propagate it with the styrene. Understand what I mean? So initiate it. Yeah, you initiate it. So what you need to do in this case is bring your free radical. I have it here, which is the phenyl radical. I have it here. So plus bring your styrene according to the equation. You have to know the structure of the styrene too. So my styrene structure, molecular formula is like this. Okay, it's like this. C H. Wherever you see this is styrene. So now, okay, in this case, something is going to happen here. Something is going to happen here. This bond has to break. This bond, this double bond, one has to break. So let's assume this one is the one breaking. So if it breaks with a single arrowhead, another one will come here. I told you that this single bond contains two dots, which is the two free radicals. So if it comes here, now in that case, as a science student, this free radical is going to combine with the one here. This dot is going to combine, this free radical here is going to combine with the free radical that is going to form here. So in that case, that means you are bringing this head to a join here, and it will be like something like this, something like this, something like this. This is it. So it now joins with a CH2. Now it's no longer double bond again, it's now a single bond, but I'm not going to write it, I'm going to represent it this way. Okay. I'm sure it's simple, right? Very, very simple. Now remember there's a free radical now forming here. This is you've started something. So once you have this is another radical now, okay? So now you are done with stage 1. You have to go into what we call propagation stage, which is the stage 2. 1, 2. So stage 2 is called propagation stage. So in this stage, you bring your free radical in the same way you brought this free radical here. You bring your free radical here to this other place, and then bring your styrene. So you bring your styrene to here and then combine them the same way you did the first one. So let me bring my free radical, which is this. Ask question in the comment section where you have issue understanding it. I'll be waiting for your comments or your question. Okay, so once you have this that is how it was. So now bring your styrene again. Okay, the same way you did the first one. So this bond is going to break again. So if this bond breaks, if this particular bond breaks, what is going to happen in this case is that you are going to have something like this, just in the same way I did. Okay, there's going to be free radical forming here. So this will join here. This place is joining with this place. So that means you first of all copy this one first. So I'm copying this one first. Okay, just the same way it was. CH. Okay, just the same way it was. Now instead of me putting this free radical, because this other one is joining, so it becomes a single bond. So becoming a single bond, this is how it is represented. Okay, now this is no longer a double bond again, it's now a single bond. So it is represented this way. Okay, I hope you are following your H. Then that free radical, the same way this one formed here, this one is also forming here the same way. You are going, they say show all the steps. That's why I'm wasting time to do this. So now I'm going to bring my radical again, my free radical again, okay, to this other side, then bring another styrene. So I'm going to just copy everything here. So I'm going to copy everything there. So what do I have? CH2, CH, my phenyl. Okay, have my CH2. I have my CH phenyl, okay, and my free radical. I bring my styrene again, my styrene, okay, CH, okay. I hope you are getting my point. So in this case, I don't want to keep bringing many of these styrenes again. So instead of me to keep bringing this many of these styrenes, I simply put N, that stands for the number of styrenes. This makes this, that stands for the number of styrenes, okay? That means there are many, so it could be 10 styrenes, it could be 50 styrenes, it doesn't matter. So I just bring my N. So what I'm going to do there is, okay, I'm going to break this place again the same way I did. So I'm not going to use this arrow again. So I've been believing you to understand this arrow. So I'm going to join here to here. I'm going to join here to here. So first of all, let me copy from here to here. So I do that by, okay, I hope you have no issue understanding me. I hope you are following up very well, because this is as simple as A, B, and C, right? Oh, I love A, B, and C. So it's as simple as A, B, and C. A, B, and C. So now this is it. This is it. My H. So this is the free radical, but I'm not going to put the free radical because it's going to combine with this other one. So I'm going to join here with J. Remember, there is N. There is N. So I'm done with this one. So this, in place of this N, I'm going to do something, because before I put this N is only affecting this other side. So I'm going to put something like this. Okay, I will explain to you, and I now bring my CH2, bring my CH, my phenyl group. Okay, in that case I close it. That's how it's the same thing. Now it has joined. For the N, I bring the N to be here, showing that the N only affects this one. Do you understand? The N only affects this side. So I'm done with my proper. That means there's no point bringing many of my styrene again, because I've used N that shows as many as styrene as I may wish to bring. So in what I'm going to do in that case, I just go straight to termination stage, which is the stage 3. Okay, 1, 2, 3, stage is 3. Termination stage, okay, stage termination. Okay, in this case, what this can be done in two ways. It can be done in by combination. So by combination, that means you simply bring two of these together. Remember, you have your free radical here, don't forget that. You have your free radical here, don't forget that. So now have your free radical here, sorry, don't forget that. Now in this case, it can be done by combination. By combination, that means I bring two of these my free radical. Yeah, that's by combination. So I can also do it by disproportionation. But let's look at by combination. By combination. By combination. By combination. By combination. So by combination method of termination, I'm going to bring my this. So in this case, I can choose to make it this way. Your benzene ring has to look well. Okay, very fine. Very fine. Okay, copy it just the same way it is. CH, my phenyl group. My phenyl group. Okay. CH2, CH2, CH, my phenyl group again. Okay. You have my, okay, you have your open bracket there. Open bracket there. CH2. See my free radical here. Before I forget it, it's very, very important. If you forget, you have a wrong answer. My H, close, N. Now, I told you by combination is you bring two of these idiots. Two of these radicals. Two of these radicals, okay? You have another one here. Another one here. Okay. Have another one here. CH. Okay, don't mind me. I'm doing what I should do. Okay. One. Remaining this one, CH2. Have another CH. Okay. You bring two of them. Okay. Now you have your brackets. You have your bracket. Okay. You have your bracket. You have your brackets. So now you have your brackets. You have your bracket. You have your brackets. You have your brackets. What do I have there again? I have CH. CH2. C, my free radical. Okay, in that case. Okay. Close N. N. So what I need to do in this case is What I need to do in this case is I use an arrow here. See the arrow? So I'm going to combine the two. So for you to combine the two, you have to copy from here to this place. Then this particular place is going to join with here. Here is joining with here. So let me copy this side first so you see how it is being done. So you see how it's being done. It's going to be cleared. CH2, CH, see, the work is simple, right? CH2, this is where I am. CH, I have my phenyl group. I have my into brackets. Okay, CH2, CH. Remember that free radical. Now, I'm going to join. Remember, I have to close it first. Okay, remember, I'm going to join this particular place with this place. So I'm going to copy from here. Joining from here to here. So I'm going to copy from here. See? So that means if I want to copy from here, I'm writing, remember I'm writing this one first. So if I put n here, but I also have another n here. So instead of putting n here and there, so I will choose not to put the n first. So I can later put one n to cover the both of them. So I will refuse to put any n there, but the open bracket is there. So I have my C, H, you see it? Very simple. This is the first one. The second one is CH2. Now I have, you see, so I can put the bracket to represent my n. So the n, because the both of them had n. This one had n, this one has n. So the both of them has n. The equation is balanced. So now copy this one, which is CH, my phenyl group. Is simple, right? Simple. Now I'm done with this one. I'm coming here. CH2. I'm done. I'm coming here. CH, my phenyl group. Is simple, right? I'm done with this one. So CH2. I'm done with this one. So what I need to do now is the last one. I now have my phenyl group, rather. I don't mind me, phenyl group. Okay, it's very simple. It's as simple as OBJ. So this method is by combination method. Maybe when we do another question, we are going to use this proportionation method. So this you were actually asked to do a show equation for. So this is the equation. The whole of this is actually the equation. Isn't it? It's as simple as that. It's actually the equation. It's not hard. It's simple. Let me keep it well for you. It's as simple as this, as simple as this, as simple as that. Or should I put it this way for you? So comment, view it, understand it, comment wherever you have any challenge. Ask your question. I am here to attend to you. Subscribe to my YouTube channel. Very, very important. It's simple, right? So thank you for watching. I value your time. Thank you for watching. Thank you for watching.